This is part 11 of the series Calculus Prerequisites, and I'm going to start this part with arguably one of the most important central concepts in all of calculus, and that's one of slope or rate of change. And as we're going to discuss when we get into calculus, calculus is the mathematics of change, and so rate of change is a central concept. Now, you've seen this way back all the way back probably before Algebra 1, but specifically in Algebra 1, you talked about slopes of lines. And you talk about the slope of a line through 2 points. And we looked at the change in the y coordinates. So y2 minus y1, that gives you the change in y's, or the rise. And the difference of the x coordinates, which is the change in x, or the run. In calculus terms, we're going to say change in y or change in x. This is the Greek letter delta, means change in. So this is the change in y over the change in x. So it's a ratio of the rate of change of y with respect to the change in x. Now, to put this in perspective, we're going to be dealing with this not in just straight lines per se, but we're going to be looking at the slopes of curves at specific points. So you may have some given curve, and we may be interested in what is the slope of a line that's tangent to that curve at a particular point. So that's going to be one of the central ideas that we're going to be dealing with. So what I want to brush you up on is how to find slope and how to use slope in equations of lines and things of that nature, because those are all going to play a factor. So let's look at finding the slope of lines. Here we have 4 lines, line L, line M, line N, and line O. And we're going to find the slope of each one of these lines. So that's all we really need is 2 points. So we can take this point and this point, or this point and this point, to find the slope of O. You know that the slope is going to be negative by inspection, because from left to right it's going downward. So this is going to have a negative slope. But let's go ahead and calculate it real quick. I know that this is probably old hat to you, but we need to go through it. So we have the difference of the y's, 4 minus negative 2, over the difference in the x's, 5 minus 13. That gives us 6 over negative 8, which simplifies to negative 3/4. So that's our slope. The rate of change of y is 3, or negative 3. So we're going down 3 and to the right 4 units. All right. So we verified that it's a negative. Now let's do M. Line M has a slope. Let's take 10 minus 4, change in y. So again, this was the change in y, change in x. So the change in y is 10 minus 4. I'm using this point and this point, and 9 minus 5. So that gives us 6 over 4, which is 3/2. So that means we're going up 3 over 2. So the rate of change of y to the rate of change of x is 3 to 2. Now let's take a look at line N, and we'll use these 2 points here. So we have the change in y is 4 minus 4 over 5 minus negative 3, which gives us 0 over 8. Well, 0 divided by anything is 0. So, as you remember, horizontal lines always have a 0 slope. We don't say no slope. We say it has a 0 slope. All right, now let's take a look at the vertical line. So this vertical line here, let's use this point and this point now. So the rate of change of y is 4 minus negative 3 divided by 5 minus 5. And that gives us 7 over 0. Well, as you know, we can't divide by 0 because 0 goes into 7 an infinite number of times. So this is undefined. So we say this vertical line has an undefined slope. And one of the central characteristics of slope, all horizontal lines are parallel, all vertical lines are parallel. All right, so that's the basic idea of how to find slope. Hopefully that came to memory pretty quick. Let's look at the issue of slopes of perpendicular and parallel lines. Now here we have two lines that appear to be parallel and one line that appears to be perpendicular, but we never trust the picture. Let's calculate the slopes of these two lines, AB and CD. So we have slope of AB is 9 minus 5 divided by 9 minus 5, which is 4 over 4, which is 1. Now let's take a look at the slope of CD. That's 8 minus 4 over 11 minus 7, which is 4 over 4, which is 1. So the slopes of parallel lines are equal. That's a fundamental theorem. And all vertical lines are parallel. Then we're going to look at slopes of perpendicular lines. In order for this line to be perpendicular to this, the product of the slopes have to be equal to -1. So we're going to look for the slope of this line. So that's going to be 3 minus 9 over 11 minus 5, which is -6 over 6. And that gives us a -1. And you can see that the product of 1 and -1 is -1. So yes, in fact, these two lines are perpendicular. So that's a really cursory quick look at the slopes of parallel and perpendicular lines. Now we're going to look at equations of lines, perpendicular and parallel. In this first problem, we want to find the equation of the line through the point 4, 3 that is parallel to this line. Well, obviously, we're going to need the slope of the line because parallel lines have equal slopes. So we've got to put this in slope-intercept form in order to get that. First thing, let's divide everything by 2 so that we can simplify this and make it a little easier to manipulate. So we have, dividing everything by 2, we have y plus x equals 3, and then y equals -x plus 3. So our slope is -1. That's the slope of this line. And we want the equation of a line through this point parallel to that line. So that means we need the slope equal to -1. Now, you could use slope-intercept or point slope. I'm going to use point slope because point slope is a central form that we're going to be using for several theorems when we get into calculus. So I'd like you to get familiar with point slope method and the point slope form. Even though you still have to be familiar with slope-intercept, we're going to use point slope almost exclusively here. So the point is 4, 3, so y minus y1 is 3 equals m, which is -1, so it's -x minus x1. Now this is an equation of a line through that point parallel to this line. But I want to put it in slope-intercept form just to make it look more convenient. So y minus 3 equals -x, we're distributing the -1, plus 4, y equals -x plus 7. So this is the equation of the line through this point parallel to that line. Now we're going to use the exact same line and the exact same point, but we want the equation of the line through this point perpendicular to this line. And we know that the slopes of perpendicular lines are negative reciprocals of each other, so our target slope here is going to be 1. because the product of 1 and negative 1 is negative 1, and so that's our target slope. So again, y minus y1 equals, this time m is 1, so it's just x minus x1. So here we just add 3 to both sides. Y equals x minus 1. And so that's the equation of the line through this point perpendicular to that line. All right, just a quick review. So now we're going to look at how to find x and y intercepts. You'll recall that the idea of x and y intercepts are where the graph of the function crosses the x-axis and y-axis. So to do the y-intercept first, we can see that the x value of the function at the y-axis is 0. So we know that the y-intercept occurs when x is 0. Y equals, put in a 0 here, put in a 0 here, put in a 0 here, plus 8, and you can see that y equals 8. So that's the y-intercept. Now for the x-intercept, you can see that the y-coordinate is 0. And this is simply the zeros of the function. Now we spent a chunk of time earlier in previous videos looking at how to find the zeros of a given function. Here we have a cubic, and it doesn't look like that cubic will factor by grouping conveniently. So we're just going to use the rational zero test, and let's start with, we know it's going to be factors of 8 divided by factors of 1, so it's going to be either 1, negative 1, 2, negative 2, and so on. Let's start with 1, and we have 1 cubed, which is just 1, minus 5 times 1 squared, which is 5, plus 2 times 1, plus 8. So this is going to give us 1 minus 5 is negative 4, plus 2 is negative 2, and that's going to be 6. So this is not a 0. Let's try negative 1. So negative 1 to the third is negative 1, and minus 5 times negative 1 squared plus 2 times negative 1 plus 8. So this gives us negative 1. That's going to be negative 5 because this is a positive 1 plus negative 2 plus 8. So this is 5, 6, 7, 8 negative plus 8 is 0. So that means negative 1 is one of our zeros. So let's just put that down here. That's one of our zeros. Now we're going to use that and some synthetic division to find the other two zeros, because we want to find the quadratic. So negative 1, and our coefficients are 1, negative 5, 2, and 8. So 1, negative 5, 2, and 8. This is negative 1, add, it's negative 6, multiply, this is 6, this is 8, multiply negative 8, and 0. So this gives us, since this is cubic, this is quadratic, so this is x squared minus 6x plus 8. All right, now let's see if we can factor this really quick. And this is positive, so these are both going to be negative because that sign's negative. And let's try 2 and 4. X squared minus 4x minus 2x plus 8. So there we go. So since one factor is x minus 2, we know the other zero is 2. And since one factor is x minus 4, the other zero is 4. Now if we were doing this formally, we would have written down points. This would have been 0, 8, and negative 1, 0, and so on. So that's finding x-intercepts. In the next video, we're going to talk about points of intersection. So I will talk to you in the next video.